Hello, welcome back to Elements of Civil Engineering and Mechanics class. Today we are going to state and prove parallelogram law of forces. So the statement says, if two forces which act at a point be represented in magnitude and direction by the two adjacent sides of a parallelogram drawn from one of its angular points, their resultant is represented by the diagonal of the parallelogram passing through the same angular point in both magnitude and direction. So that's what the statement of the parallelogram law of forces says. Next, we will go to the proof. So I am going to write this same two forces. So that is the force P and the force Q, and if this is theta, that is the angle made by one of the forces with the other. So complete the parallelogram, and this are drawn to certain scale. What I mean to say is, if Q is 10 kilonewton, if 1 kilonewton equal to 1 centimeter, then this should be equal to 10 centimeter. Similarly for this P. So complete the parallelogram, join the two corner points, that is the diagonal, that represents the resultant. Let alpha be the angle made by the resultant with respect to one of those two forces. So to prove or to find out what is the resultant, what I am going to do is, I am going to draw a perpendicular here, and I am going to continue this line. I am going to call this as A, B, C and D. Now from triangle OCD, from triangle OCD, which is a right angle triangle, by applying Pythagoras theorem, OC square equal to OD square plus CD square. I am going to call this equation 1. So what is OC? OC is basically R, that is the resultant, that is OC equal to R. Then what is OD and what is CD? So here in this, OD is equal to OB plus BD. So what is OB? OB is nothing but Q, that is Q plus what is BD? So BD is, if you look here, this is parallel to this. So this is the common line between these two parallel lines. So this is theta. So this should be theta as well, because these two angles are corresponding angles. So once this is theta, and we know this is P, this is same as this. So I am going to write this as P. Then here BD becomes P cos theta, that is cos theta equal to BD divided by the hypotenuse, which is BC. So BD equal to P cos theta. In this equation I am going to write BD equal to P cos theta. Okay. Next we will come to CD. Again in this triangle, that is triangle BCD. Sin theta equal to opposite side CD divided by the hypotenuse, which is P. So CD equal to P sin theta. So again CD equal to P sin theta. Now I am going to substitute all these values, that is all the three values in this equation. By substituting all values in equation 1, we get, so for OC it is R, so OC square equal to R square equal to OD is Q plus P cos theta, Q plus P cos theta square plus CD equal to P sin theta, so CD square equal to P sin theta whole square. Simplifying further, Q square plus P square cos square theta plus 2PQ cos theta plus P square sin square theta. So by taking these two first, P square is the common factor, sin square theta plus cos square theta plus this is Q square plus 2PQ cos theta. So sin square theta plus cos square theta equal to 1. So that is P square plus Q square plus 2PQ cos theta. Okay, this is R square. Therefore, the resultant R equal to square root of P square plus Q square plus 2PQ cos theta. Next, so this gives the magnitude of the resultant, but we don't know the location of the resultant R. That means at what angle the resultant acts with respect to one of the two forces. So let us say alpha is the angle made by the resultant with respect to the horizontal force Q. So to find the angle alpha, again from the triangle OCD, tan alpha equal to opposite side, that is CD divided by adjacent side, that is OD. That is tan alpha equal to CD. What is CD? This is P sin theta. That is P sin theta divided by OD is OB plus BD. So what is OB? Q plus BD is P cos theta. So it is Q plus P cos theta. Therefore, alpha equal to tan inverse of P sin theta Q plus P cos theta. This is how we are going to find out the angle the resultant makes with respect to one of the forces. I hope this is clear. So I am going to call this as equation A, and I am going to call this as equation B. Next, what if theta equal to 90 degree? Then this becomes a rectangle. So if theta equal to 90 degree, then this is going to be a rectangle So P is the force and Q is the force and O is the angular point. So this is theta equal to 90 degree, and this diagonal represents the resultant of these two forces both in magnitude and direction. So if this is alpha, that is the angle made by the resultant with respect to this force. So we are going to find out what is going to be the resultant if theta equal to 90 degree and what is going to be the value of alpha if theta equal to 90 degree. So what we are going to do is we are simply going to substitute the value of theta equal to 90 degree in this equation to get the resultant. Similarly, we are going to substitute theta equal to 90 in this equation as well to get what is the value of alpha. So by substituting the value of theta equal to 90 degree in equation 1, we get R equal to, this is not equation 1, this is equation A, R equal to P square plus Q square, and if I put theta equal to 90 degree, cos 90 is 0, so the whole thing will become 0. I am left with R equal to square root of P square plus Q square. So if you look at this rectangle, yes, this is the hypotenuse and these two are the remaining two sides of the right angle triangle. So obviously by applying Pythagoras theorem, we are going to get R equal to square root of Q square plus P square. Okay, it is the same here. And in equation B, that is by substituting the value of theta equal to 90 degree in equation B, we get alpha equal to tan inverse of P sin theta. P sin 90 is P because sin 90 equal to 1, Q plus P cos theta. Cos 90 is 0, this will become 0. So P divided by Q is the angle made by the resultant with respect to the horizontal here. I hope this is clear. So this is what the law of parallelogram law of forces and its proof. Next. Now we are going to talk about triangle law of forces. So what does it say? What does it say? If two forces acting simultaneously on a point can be represented both in magnitude and direction by the two sides of a triangle taken in order. Taken in order in the sense it may be taken in the clockwise direction or anti-clockwise direction. Then the magnitude and direction of the resultant can be represented by the third side of the triangle taken in the opposite direction. So what it means is, see, we have two forces, P and Q. Okay. Again, as I said in the previous proof, say P equal to say 100 kilonewton, we are going to take a scale of 10 kilonewton equal to 1 centimeter. So for 100 kilonewton it is 10 centimeter. Similarly, say Q equal to 75 kilonewton, that means to a scale we can draw that length equal to 7.5 centimeter. So in this case, the way we are going to find out the resultant is, first we are going to take any one of these two forces. Okay. So P is the force I am going to draw here. Okay. And I am going to draw this P to this scale, and this P should be parallel to this. So that is like this. Okay. And this is P. Next, we go to, you can go in the clockwise direction or you can go in the counterclockwise direction. It is one and the same. So if I take this force, what I do is, again I am going to draw another line starting from here, from the point where you see the arrow, and this line should be parallel to this force, and the length should be equal to whatever the force magnitude is to this scale. So I am going to draw this Q. Okay, if this is 10 centimeter for 100 kilonewton, say if this is 75 kilonewton, 75 centimeter, and this is parallel to this and this is parallel to this, and it should be taken in the same direction, means this is drawn like this, and where we see the head of the arrow should be the starting point for the other force, and this force should be equal to 7.5 centimeter, that is 75 kilonewton, and this line should be parallel to this. Then join this point and this point and take in the opposite direction. See, the arrows are moving in this direction. Okay, and this resultant arrow should be acting in the opposite direction. Arrows like this, resultant should be opposing. So that means this head is touching with the head of this force, and this represents the resultant. So measure this distance, convert that back to scale, and find out what is the magnitude of the force R. And if you measure the angle on a drawing sheet, so whatever the angle you are going to get, say theta, that is the angle the resultant makes, that is the resultant of these two forces makes with respect to one of the forces, here with respect to the force P. So with this I am going to go with the definition once again. If two forces acting simultaneously on a point, see this is a point, say if I call this as O, can be represented both in magnitude and direction. Both can be represented both in magnitude and direction by the two sides of a triangle. This is a triangle, these are the two sides of a triangle taken in order. That is, I am going to take this force, next one is I am going to go with this. So you can take this anti-clockwise direction or clockwise direction. Okay, that is nothing but take this force, draw parallel. Okay, then the magnitude and direction of the resultant can be represented by the third side of the triangle taken in the opposite order. I hope this is clear, and this represents the resultant. Measure this, say for example this is say 12.5 centimeter. That means it is 12.5 multiplied by 10. 125 kilonewton is the resultant of these two forces, and this is the direction in which the resultant is acting. And if you measure the angle on a drawing paper or drawing sheet, so this is the angle the resultant makes with respect to the force P. So that's what the triangle of forces says. So we are going to extend this for multiple forces. Here we have only two forces. What if more than two forces are acting at a point? Then we are going to make use of polygon law of forces. See, look at this. This is the point on which we have four forces acting. So how to find out the resultant of these four forces? Graphically. See, again along the same lines, this also says the same thing. Here it is multiple forces. Here it is two forces. So I am going to read out. If a number of coplanar concurrent forces, yes, these are coplanar forces, they are acting on a single plane, and concurrent because they are acting at the point O, that is at a single point, or acting on a body such that they are acting, say just take this point as a body such that they can be represented in magnitude and direction by the sides of a polygon. Polygon means so multiple sides of a closed figure taken in an order. Their resultant is represented in both magnitude and direction by closing side of the polygon taken in the opposite order. So by closing side of the polygon, what it means, once I draw the figure, you are going to understand what exactly it is. So first what I do is, I am going to take this force F1. So this will have some magnitude, say 100 kilonewton, 10 kilonewton equal to 1 centimeter. So 100 kilonewton, it is 10 centimeter. So what I do is, I am going to draw a line here to some scale, okay, and this force should be parallel to this, and this should be in the same direction. That is, the arrow should be pointing in the same direction. So this is F1, okay. Next, so I can come F4 anti-clockwise, or I can come clockwise direction. What it means is, next I can go with F4 force, F3 force, F2 force, or I can come like this, F2 force, F3 force, F4 force. Okay, now I'm going to go with in the clockwise direction, I am going to go with F2 force next. So if I go with F2 force, so from this point where this arrow head is there, I am going to draw a line, okay. So magnitude equal to F2, and the direction is this, exactly like this, and to this scale. Next, if I take this force, see, once you start clockwise, you should complete all the forces in the clockwise direction, or else if you consider anti-clockwise direction, you should complete in the anti-clockwise direction itself. So after drawing F2 here, so we'll go with F3. F3, from here you draw F3. F3. So the length of this force should be equal to the force magnitude to this scale, and this should be parallel to this force. Next, coming to this F4, this force. So you draw F4 like this. So this should be parallel to this, and the length should be equal to magnitude of the force F4. This is where the force F4 ends. So we have exhausted all forces here. So this is where F1 starts. Then there is a space in between. Join that and put the arrow in the opposite direction. So this represents the resultant. And this angle, if I call this angle as theta, and theta is the angle made by the resultant with the force F1. So now I am going to go back to the definition. I am going to explain once again so that you can understand clearly what exactly it is. So it says, if a number of coplanar concurrent forces are acting on a body, yes, number of concurrent coplanar forces acting on this body, that is point O is the body, such that they can be represented in magnitude and direction. They can be represented in magnitude, that is the length of the arrow, and direction, that is same as the force direction, okay, by the sides of a polygon. Yes, this is a polygon. This is one of the sides of the polygon taken in an order. So how we are taking the forces? We are taking the forces in the clockwise order. If you want, you can go ahead and take in the counterclockwise order. That is how finally you will end up getting the same resultant value. Taken in an order, their resultant is represented in both magnitude and direction by the closing side of the polygon. This is the closing side of the polygon. Okay, taken in the opposite order. See, all these forces are acting this way, here, and the resultant is this, acting in the opposite direction. Then measure this, whatever the measure. Say for example, this is say 7.5 centimeter. So what is the resultant of all these forces? It is 75 kilonewton. Okay, and measure this angle, okay, using a protractor on a drawing sheet. So whatever angle you get, okay, that is the angle made by the resultant with respect to the horizontal. So you can also solve this problem theoretically, which I am going to do next. Okay, you are going to get the same values. Of course, with little bit of error. When you are doing drawing, there will be some errors. But when you are doing mathematically using your calculators, so you are going to get the exact value. I hope this is clear. Thank you. I'm going to talk about the equilibrant of a force next. So what is equilibrium of a force? So here I have got a set of coplanar concurrent force system. Okay, coplanar concurrent, these two forces are divergent force and this is converging. Doesn't matter, you can take any combination. And also you can apply polygonal law forces as I explained before, even for this, even though one of the forces is converging. Okay, it is the same procedure. So if I take this case, I have four forces, so acting at point O. So by graphical method, as I explained in the previous polygonal law forces, or mathematically you can find out what is the resultant of these forces, and also we can find out what is the magnitude of the resultant. So once you find out what is the resultant value and the magnitude of the resultant and the direction of the resultant, so you can draw this resultant like this. Say this is the resultant. I am just simply assuming this is the resultant. So what it means is, so whatever the point O or the body at O is going to move in the direction of the resultant. That means if these forces are acting at point O, then the body or the point O is moving in this direction. So that is nothing but that is the direction of the resultant. With certain magnitude of the force, the magnitude of the force is the resultant value. Then comes what is equilibrant. This is the force called equilibrant. So equilibrant is the force acting in the same, along the same line of the resultant force, but in the opposite direction, whose magnitude equal to this, same as the resultant. That is equilibrant. So what is the job of the equilibrium? Job of the equilibrant is to keep the body in check or just in static position. So the body does not move if you apply the equilibrant. That means you can take this force R dash and you can apply here, then this point O will not move. In other words, I am going to repeat, equilibrant is the force whose magnitude equal to the resultant, okay, and acting in the same direction or same line, along the same line as the resultant, but in the opposite direction. And the job of the equilibrant is to keep the body stationary. I hope this is clear.